Assalamu alaikum dear students. So today we have a session on the integration. So we go in the content and we look for the in-class activities, and we have the new chapter called integration, and we have a sheet for us to work. This sheet contains about some questions. They are all related. So what we're going to do, I have solved few for your information and understanding. So this is the sheet. Now the first part is the differential. Now differential is very similar to derivative. Actually we don't do anything new, but rather we just represent a different way. So this is an expression that we had, right? And then we are required to find dy, not dy by dx, only dy. So we do the business normal, as we say here, we simply take the derivative as before. So I took the derivative, right? And you can see that this is a chain rule. So I take the derivative of the power first, and with this half power minus 1 is negative half power. And then I take the derivative of the expression, which is 3x squared minus 4, so that will be 6x. And then if I rearrange, so this goes in the bottom, becomes root, and this 6 cancels with this 2 makes 3, and this is the x, so I left over this. So far this is dy by dx equals to this number. What I would do, I would just move the dx from here, which was in the bottom, to here, and that makes the dy. So basically dy is moved from here to here, and dx comes here. So this is the only new thing in here. Now somebody would like to ask you a question about how to compute a number. Suppose you know y, this is the relationship between y and x in differential, and you want to know initially the value of the y when x is 0 is 8, and what is the value of y when the x is 1. So we take the advantage of the derivative. You know the derivative measures the rate of change. So what we're going to do, we'll look into this. We have the derivative, we take it to the other side. So dx move to the other side. It was in division, comes in multiplication here. And remember that in the study we recall that a dx is basically the change in x, or dy is also the change in y. So basically you can write it here that delta y, which is change in y, and delta x, right? So what we're going to do, we know the change is how much? We are going from where to where? From x is equals to 0 to x is equals to 1, right? So the total change in x is 1, right? So this is the 1. And then I replace initial value of x is 0. And the change in x is 1. So I need to know what is the delta x. I know that at x is equals to 0, this is the value of y, which is 8. And the change in y due to change in x, which is change in x is from 0 to 1, right? How much is the change in y? Minus 3. So I put this minus 3 in here. And this is the new value of y, which is at 5. So this is how you use the differential to compute the new value of y. Now we have a new domain of study which is called antiderivative, or the indefinite integral. Why we call them indefinite? Because there are no limits in the integrals. Now integration stands for summing up. So basically you are summing a continuous number. Now this is the reason that it comes from the capital letter called S. You can see it's an S, stretch S. Now the integration is very similar to differentiation, but opposite. What we're going to do, we have this expression to integrate. In integrate, when you have the expression, you divide the expression into multiple expressions. So I divide 2x upon 3 and 1 upon 3 with dx. Now what I can do, I can break this into two parts. One part with this, and the second part is this, right? Notice here that the only x is a variable. So this 2 upon 3 is a constant, and 1 upon 3 is also constant, taken out. Now when you have a derivative, remember that in derivative we have the powerless. Here we have a power of addition. So basically if you have x to the power n, you have x to the power n plus 1 divided by n plus 1 plus c, where c is the constant of integration. Notice here this formula is valid for all values of n except negative 1. So using this formula, if you divide this, then this will be, how much is the power? 1, right? So it will be 1 plus 1 and upon 1 plus 1, and here there is no power, right? But you know that differentiation and integration are the opposite to each other. So differentiation and integration sign, which is the sign, this and this, they cancel each other and you left with this x. And after you complete the integration, you put the integration sign of integration constant. So you can cancel 2 with 2 and you get x squared upon 3 plus 1 upon 3x plus c. So this is an answer to this question. Now here we have integration question, right? But this time the x is in bottom. So what I'm going to do, that I know that this is the power of how much? 1 upon 4th, right? So I can write it here 1 upon 4. I can bring the x up, which is negative 1 upon 4. And then I again use the power rule. But here how much is the power? Negative 1 upon 4, right? So I'm going to use this power rule. So this is negative and 1 upon 4 plus 1. Negative 1 upon 4 plus 1 plus c. And then I subtract, so this is 1 minus quarter, which is 0.25, makes 3 upon 4, right? And similarly 3 upon 4 in the bottom plus c. So, and if you can notice that this is in the bottom, if you reciprocate, this will be 4 upon 3 x to the power 3 upon 4 plus c. So this is the answer to this question. So we have the next question here, which is e to the power 2 dx. Notice here that when the dx sign is there, it shows you who is the variable. So this is x is a variable. Now this is the sign of integration, which is the sum sign. Notice here that e to the power 2 does not contain any x, so it is taken out. Now notice here, since nothing is written, meaning 1 is written, and you know that x to the power 0 is 1. So you can also write, instead of 1, you can write x to the power 0, and you can also apply the power rule in this case, right? So in this case n is 0, so it's power n plus 1, which is 0 plus 1 and 0 plus 1. So this is going to give you 0 plus 1 is 1, so 1 is not written, and x to the power 1 plus 0 is 1. And this is the answer to this question. And this is the similar way of that you can cancel the sign with the integration sign. Now in here, the question is a little bit longer, but here you can take the advantage that this is the constant, so it's taken out, right? And left over is 2x minus 1 and 3x minus 2. So you can expand them, and the idea in integration is that you need to divide them. You can make as much pieces as you would like to make for. So I made the pieces, so I multiply each term. So 2x times 3x is 3x squared, 2x minus times 2x is 4x, and then minus 3x makes 7x. And then this is multiplied by this, which is 1 minus 2, which is plus 2. So you now break the integration sign into each of these. So this is the integration of 6x, and then minus 7x, and then 2. Now what you can do, you can take the constant out. So I took the 6 out, 7 out, and 2 out. And again I use the power rule. So in this case the power is how much? 2. So it will be 2 plus 1 upon 2 plus 1. Minus 7, 1 plus 1 upon 1 plus 1. And with the same principle, that d sign cancel with the integration sign. So d sign opposite to each other. So left over is x. Plus c. C is the constant of integration, which is used when you have an indefinite integral. So this is the simplification that you can apply after this. The next question is very similar, but a little bit having a fractional power. So these fractions power are there. The easiest thing that we can do is that to break, like you always do break. So what we do, we break this term into two pieces, and notice that the 1 upon x to the power 1 upon 3 is written in each of these. Now what you know, the x upon 1 upon x to the power 1 upon 3 is in bottom, so we can bring it up, so it will be 7 upon 3 minus 1 upon 3. And similarly in here, 11 is a constant, the coefficient, but x to the power 3 5 upon 3 minus 1 upon 3. So this is the sum. So when you sum the powers, you're going to get this, which is 7 minus 1 6, 6 upon 3 is 2. And similarly 5 minus 1 upon 3 is 4 upon 3. So this is the answer so far. And then what we do, we take simplification. So we imply the integration sign to each of these terms. So this is how we employ. And then we take the constant out, which is 8 and 11. And then we again apply the power rule. So if you apply the power rule, it will be, how much power is 2, right? So it will be 2 plus 1 upon 2 plus 1, which is power 3. minus 11, 4 upon 3 plus 1 and 4 upon 3 plus 1. So you can simplify, it's going to be 7 upon 4 and then 7 upon 3 and then it will be 7 upon 3. Notice that since it's in bottom, so it can come in the top by reciprocal. So it will be 3 upon 7 in that case. And then 3 times 11 makes 33. So this is the answer. And notice that as soon as the integration sign is off, here the integration sign was on. As soon as no integration sign, you see the constant of integration in all the steps. Okay, so this is how you work with this tutorial. I hope that I explained to you the basic concepts. So actually the concept is only to use this power rule of integration and break the terms as we like to. Notice that the power cannot be -1. Other powers are acceptable.